So today we are working on our applications with our sequences. So it's not really always going to tell you whether it's arithmetic or geometric. You just need to know that. You need to be able to figure out by the problem whether it's increasing by addition, which would be your arithmetic, or if it's increasing by multiplication, which would be your geometric sequences. So let's take a look at our first example. We have Carrie borrowed money interest-free to pay for a car repair. She's repaying the loan in equal monthly payments. So they want us to write an explicit rule for the sequence of the loan balances using n and f of n. So they want us to write it in function notation. So let's take a look at what we were given first. We got to first figure out what is this going down by. Is it going down by subtraction, or is it going down by division, which would be our geometric? So since looks like it's a nice steady increase, this one goes down by 120, and then from here to here it's down another 120, another 120, down another 120. So this is going to be an arithmetic rule. So if you remember our arithmetic formula would be that. But again, I didn't use the right notation. They wanted me to use f's instead of a's. So this should be f of n equals. Our first term is 840. N is going to stay as n. And our common difference is our negative 120, because that's what it's going down by. So I'm going to distribute here. So I get f of n equals 840 minus 120n plus 120. So just cleaning that up a little bit more, we get negative 120n plus 960. There is our explicit rule. So then they want to know how many months will it take Carrie to pay off the loan, and then we need to explain. So we got a couple ways that we can do that. We can take our formula that we just wrote, and we can set it equal to 0. We set it equal to 0 because if you pay off the loan, that means you owe $0 still. So then I would subtract my 960. And then divide by my negative 120. So you would get n equals 8. So it would take 8 months for her to pay this off. So 8 months. Another way you could have done it is you could have just kept going, subtracting 120. So that's 6 months, it would be 240. 7 months, it'd be 120. So at 8 months, you'd get your 0. So you could get it that way also, just by following your pattern there. So then for explain, how many months will it take for her to pay off the loan? Explain. It'll take 8 months, comma, because that's when the balance is 0. So then they wanted to know how much money did she borrow initially, and then we have to explain. So initially, she borrowed $960. That's our B value of our equation. Meaning, I looked up here. Oops, a little too far. This is an mx plus b form. So b is always where we begin. She began by borrowing $960. So that's our answer for that one. That one's a little easier of an application one. 2, suppose you drop a bouncy handball from a height of 10 feet. After the ball hits the floor, it rebounds to 90% of its previous height. About how high will the ball rebound after its 5th bounce? So as you can see, we set up a table here. This one starts at 0 because at time 0, the ball is at 10 feet high because that's where you started from a height of 10 feet. So then to get to the next number, it's 90% of that. So I got to multiply times 0.90. So that's going to give me a 9. And then times 0.90 again, that gives me an 8.1. Times 0.90 gives me 7.29. Times 0.90, 6.561. And then times 0.90 again, we'll round this to 5.9. So to answer this question about how high will the ball rebound after its fifth bounce, about 5.9 feet. So how is each term in the sequence related to the one that came before it? It's 90% of the previous number. We just took each number, we kept multiplying it times 0.90, which is our 90%. So down here, on the coordinate grid below, sketch the path of the bouncing ball to the correct height. If you connect the maximum points, what type of graph does it become? All right, so let's see here. We already got our numbers on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at time 0, we had 10. And then we're going to go to 1, 9, 2, 8.1, 3 is 7.29, 4 is 6.5-ish, 5 is 5.9. So this kind of starts rounding out a little bit there. So if you connect the maximum, what kind of graph does this become? It becomes an exponential decay. So they want us to write a recursive formula for the rebound height of the bouncy ball with the initial height of 10 feet. So our recursive formula. This time our recursive formula is going to be a little bit different. Because instead of having a first term, we're going to start with term 0. So that's going to make everything a little bit different. So we start with term 0. And then what we're doing is we multiplied everything times 0.9. So it's 0.9 times your previous term, our a sub n minus 1. For our explicit formula, again, since this one is exponential, I'm thinking to myself, a times b to the x. A is my initial. B would be what I'm multiplying times. So this would be a sub n. And again, it starts at 10, which is our term 0. So we still want to keep the 10 there. And then it's 0.9, and this time it's just going to be to the n power. Because when you plug in your 1, 10 times 0.9, that's how we get our 9 up there. You don't want to do the n minus 1 for this one because it starts at 0 as opposed to the 1. If it started at a 1, we would do our n minus 1 just like we've always done. So that one's a little trickier. So example 3, we have Carmela's annual salary in year n can be modeled by this equation here, where C of 0, again, this one starting with 0, is 75,000. So what you have to keep in mind is that here we have a notation we don't really see that often. That refers to our next term, which in this problem is our next year. So they want to know, what does the number 1.05 represent in the context of this problem? Now this is a recursive formula, so this just means the current year, because it's just n. So to find the next year, you're taking the current year times this 1.05. So this is very much so like our exponentials that we dealt with before. If we were a 1.05, because it's greater than 1, this was a growth. So we kind of took the 1 off, and you move the decimal over 2 places. So this means it's a 5% increase each year. They want to know, what does the number 75,000 represent in the context of the problem? That's her pay. I don't know why I started writing it to her pay the first year, which would be the beginning. So if you think about it, during her first year there, that's from time 0 up to time 1, and that's when your n becomes 1, is after the end of the first year. That's when she gets her first increase. So then they want us to write the explicit formula for this sequence. Again, this is another exponential, so you want to be thinking to yourself a times b to the x. So we're going to use a c, because they were using c up there for all of them. So c of n equals, our initial amount was $75,000. It's being multiplied times the 1.05 each year, and our exponent would just be an n, because again, we started at a 0. Our initial was a 0, not a 1 this time, so our exponent is going to be just an n. All right, example 4, we have a pond currently has 2,000 trout in it. A fish hatchery decides to add an additional 20 trout each month. In addition, the trout population itself is growing 3% per month. Write a recursively defined sequence that gives the population of trout after n months. They want us to use p of n. They want us to start with p of 0 equaling 2,000. So that's going to be the first part of there. Since they gave that to me already, I'm going to write that. So starting with 2,000, so what we have to keep in mind is it's growing on its own by 3%. So that's going to be 1.03 times p to the n minus 1, which just means our previous term. So there's our growth by our 3% each month. But then we have to add a 20 in here because they also add an additional 20 trout each month. So this formula is a little bit different. So you got your growth, and then you got your additional 20. So they want to know how many trout are in the pond at the end of the second month. So since we have a recursive formula, as we know, we have to figure out the terms before it. So month 1 is going to be 1.03. That means my previous, so times my previous month of 2,000. And then plus a 20. So we multiply that out, add our 20. We've now got 2,080 trout. So then for the second month, 1.03 times 2,080 plus a 20, that's an 8 or a 0. Multiply it out, we do have to do some rounding. We get 2,162. So how many fish are in the pond at the end of the second month? 2,162 fish, or trout. So then they want to know third month, so I'm just going to keep going. 1.03. I'm going to put one of my decimals in there this time because that's going to make my answer a little bit more accurate. If you're going to keep going, you want to try to make it as accurate as you possibly can. So this gives me 2247. So at the end of the third month, we have 2,247 trout. Example 5. So we have the chromatic musical scale contains 13 notes. All the notes on a piano, both white and black keys. From one note to the note an octave higher, the frequencies of the notes form a geometric sequence. The 13th frequency is twice the first frequency. What is the common ratio of this sequence? So a lot of different things here. If you're not familiar with a piano, it's telling you up here you've got 13 notes between your white keys and your black keys before you hit the next octave. So that's meaning going from a C to another C, because on the piano those letters are all repeated. couple of little side notes here for us, a little information for those of you who did not know. So we're going to call these notes. Middle C has a frequency of 263 hertz. The octave above it, one octave higher, still on a C, they just don't call it middle C anymore, is 526 hertz. So that kind of shows you how it increases a little bit. And then another little side note is musically, each step is called the half step. So just a little side notes there. Music and math, oh, they go together so well. Just wait until we get to our trig unit, next unit. So again, we're talking about 13 numbers. So here's my first, second, third, fourth, fifth, sixth, seventh, 8th, 9th, 10th, 11th, 12th, 13th. So it tells me the 13th frequency is twice the first frequency. So I'm going to call my first frequency X. My 13th is going to be 2X. So what we're trying to do is we're trying to figure out what is our common ratio. So to get that, we're going to use our geometric formula still, because they told us it's a geometric sequence. So a sub n equals a sub 1 times r to the n minus 1. And what we're going to plug in is the x and the 2x. We know our 13th term, so I'm going to put 2x in for that. First term is x. R we're trying to look for, so then that's going to be to the 13 minus 1 power. So then when I divide by x here, it cancels on both sides. So I get r to the 12th power equals a 2. Going back a couple units, I have to raise this to the reciprocal power. So when you plug that into the calculator, you get r equals 1.059. So there's our common ratio for that one. Doesn't seem like you had enough information for it, but you definitely did. Okay, next one. This is our last page of notes here. So we have the product of the second and the fifth term in a geometric sequence is 288. If the sixth term is 96, what is the first term of the sequence? So I'm going to put my little lines here. 1, 2, 3, 4, 5, 6. So I know my sixth term is 96. We're trying to find that term right there. So in order to find that term, we need to know what our common ratio is. What is our R value? Looking at this again, it does not look like you have enough information. You know the second and the fifth multiply to give you 288, but beyond that, we don't really know anything. So what we do know is if I were to go backwards to get from my sixth term to my fifth term, I would have to divide by my common ratio. Because again, normally, remember, going up we multiply, going backwards we would end up dividing. So really my fifth term I could say for right now is 96 over r. Now to get my second term, I could keep dividing by r, and all that does is it changes the exponent on your r. So really your second term is 96 over r to the fourth, because you would just keep dividing by r, divide by r, divide by r, divide by r. So now what I can do, my second term times my fifth term needs to equal a 288. So let's multiply across. So 96 times 96 is 9216 over r to the fifth equals 288. So we'll put this over 1 so we can cross multiply. So my 9216 equals 288 r to the 5th. So I'm going to divide by 288. When I do that, I'm going to go up over here. I get 32 equals r to the 5th. So then I do my reciprocal power. I'm going to raise this to the 1/5 power. So I now have that my r value is a 2. So now I'm going to go through and divide everything by 2. So 96 divided by 2 gives me 48. Divide by 2 gives me 24. Divide by 2 gives me 12. Divide by 2 gives me 6. Divide by 2 gives me 3. So our first term is a 3. So again, second example, we have the sequence 64 blank 100 could be arithmetic. What would be the missing term? Well, we would first have to find our common difference, which remember is us using our slope formula. This is our first, second, third term. So 100 minus 64 over 3 minus 1. That would give us an 18. So if I add 18 to this, I end up getting 82. That's plus 18. And then just to check, plus 18, that would take me back to 100. So next, we have the sequence 64 blank and 100 could be geometric. So they want to know what would be the missing number. What else could it be? So let's see here. Again, we have our first, second, and third term. So I'm going to plug it into my geometric formula to get my r value. So this would be 100 equals 64 times r to the 3 minus 1. Divide by 64. That gives me r squared. Take the square root of it, and r equals plus or minus 10 over 8, which is really plus or minus 1.25. So if I multiply 64 times positive 1.25, I get an 80. Or times a negative 1.25, I get a negative 80. So it could be 80, or it could be negative 80. And then our last one here, we have, suppose you have an arithmetic progression where the common difference is 3. If 1, 4, and 19 are added to the first, second, and third term respectively, the resulting numbers form a geometric sequence. Find the original numbers. So this one's confusing. But we have to keep in mind our D is a 3. So since I don't actually know our numbers, I'm going to call my first term x. My second term would be x plus 3 because I got to add 3 each time to get to the next one. And my third term would be x plus 6 because, again, got to add 3 to get to my next term. So this would be our first 3 terms of our arithmetic sequence, the first one that they talked about. They then tell us that 1, 4, and 19 are added to those terms respectively. Now that phrase respectively means 1 is added to the first term, 4 is added to the second, 19 is added to the third. It goes in order. So then of my geometric sequence, I would have these terms. So this is our geometric sequence. So now what we have to do is we have to figure out our common ratio. That's going to help us figure out our answers here. So for this one, remember, second term over the term before it, that gives us our common ratio. It has to be equal to the third term over the second term. So now we can do some cross multiplication here, which I know you guys love so much. So x plus 7 times x plus 7 equals x plus 1 times x plus 25. So multiply these all out. I get x squared plus 14x plus 49 equals x squared plus 26x plus 25. So now I'm going to start trying to get some stuff together. Subtract my x squared, and it actually ends up canceling on both sides. Which I don't know why I wrote that all the way down there. I'm going to come up here with it. So I got 14x plus 49 equals 26x plus 25. So I'm going to subtract my 25 over, subtract my 14x over, divide, and we got x equals 2. Which I don't know why I started writing a 3. That's definitely an x equals 2. So they told us to find the original numbers. I already have one of them. My first original number was 2. Add a 3 to it. My second original number is 5. And then add 3 more, and it would give me an 8. And those were our 3 original numbers. So again, it's just you being able to manipulate the different formulas and remembering difference between geometric and arithmetic.